To continue on, finishing up section 1 for today and get into section 2.1. So yeah, as you know, we're moving right along here, and we will have our first test after we finish up chapter 2. You have those dates on the syllabus, so you should be good to go with that. All right, so we're starting to build this inventory of things called identities. Okay, identities. A left side is identical to the right side. It equals the right side. And we're going to be able to interchange things. And we'll talk a little bit more about that shortly. But we're going to keep building these identities. And I'm going to give you a sheet for the test. And it's going to have identities on. And you're going to be able to use that one particular sheet for the test. Nothing else, just that sheet. Okay. So I'm going to go back to something we already know. And this is the whole Pythagorean theorem, x squared plus y squared equals r squared when I'm dealing with a right triangle. And we're, that's all good. We're happy to see that. And again, it's only for a right triangle. A little bit later, we're going to be dealing with triangles that aren't right triangles and how some things change, and we won't be able to use the Pythagorean theorem. So let's take a look at this Pythagorean identity. And I'm going to take a look at, okay, we had something a little bit ago where, what if I divided everything on both sides by r squared? So if I do that, I'm going to get x squared over r squared plus y squared over r squared, and that's going to equal 1. And that's okay. I'm allowed to do that. Divide everything on both sides by r squared. And in math, you do that a lot, dealing with equations. Divide everything on both sides or multiply everything on both sides. So I get this little x, but now that I look at this x over r kind of looks familiar. This y over r, I've seen that before in this class. And I'm going to go back to something along the lines of, I'm going to make this a theta. And I kind of remember when dealing with the triangle, the ever popular SOHCAHTOA. And when I do that, I quickly go, okay, the sine of the theta was opposite over hypotenuse. So the sine of theta is y over r. So what's y squared over r squared become? That's the same as the sine squared of the theta. And the x over r with my theta, that's the cosine. That's the adjacent over the hypotenuse. So this guy becomes the cosine squared. And as a result of knowing the fact of this Pythagorean identity, calling this angle theta, I come up with my first Pythagorean identity with the trig function, and that's sine squared plus cosine squared of theta equals 1. That's gold. You're going to use, should I zoom in a little closer? Does that help?
Yeah, that helps.
Okay. This fella right here is gold. That's a new identity. That's going to be on that identity sheet. And you're going to use this over and over and over. Well, that's one of 3 Pythagorean identities. This is the one you're going to use like most of the time. But I'm going to take this sine squared of theta plus cosine squared of theta equals 1. And I'm going to come up with another identity. I'm going to take everything on both sides, divide it by sine squared. Divide it by sine squared. And finally, on the right side, sine squared over sine squared is 1. Nice. What was cosine over sine?
Cotangent.
Excellent. This guy becomes the cotangent squared. 1 over the sine squared. Remember what that was?
Secant.
Not the secant.
Cosecant.
Yeah, the cosecant. And again, this is another one of those. The more you come to class, the more you're participating, the more you're gonna remember, you know, oh yeah, 1 over sine was cosecant, because it's that repetitiveness. There's my second Pythagorean identity. Finally, I'm gonna come up with a third one, sine squared of theta plus cosine squared of theta equals 1. And this time I'm gonna divide everything by the cosine squared. Sine over cosine, that's going to give me the tangent squared plus 1 equals the secant squared. So that's where these things come from. And now that we've discovered them, we can use them. It started with this Pythagorean theorem. We created our first Pythagorean identity, and used it to find the other two. What do you think about that? Thomas, thank you. I got 1 thumbs up. Okay, so I want to now go back up here and say, oh yeah, the sine was opposite over hypotenuse. The sine, and now I'm going to move down to here. This is where a big, nice whiteboard in the classroom would work. So up here I have the sine of theta. The sine is opposite over hypotenuse. The sine is y over r. The sine of theta is y over r. I wrote it down here. Something that's going to come back occasionally. You're going to see it once in a while. The cosine of theta is x over r. Okay, we're just beating on this triangle up here over and over and over. So now I have the cosine, da, 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 da. So these are both over r. And when I look back up at my original triangle, can y ever be bigger than r?
No,
No. Can x ever be bigger than r?
no.
No,
No.
no. So they can't be bigger. So when I'm looking at these fractions, my numerator is always going to be smaller than my denominator. In both of these cases. And I can keep writing fractions that say that it's always going to be smaller. One case does exist, and that is I can have 1. Remember, we can also do negatives on any of these at any time that we wanted. So whenever I'm dealing with the sine of theta and the cosine of theta, one of the things I learn is that the sine of theta's value is going to be between -1 and 1. And it doesn't make much sense right now, but we'll get back to this several times. You go, oh yeah, cosine, it can never be, so the cosine of theta can never be 1.9. That's just never going to happen. This side will always be between -1 and 1. The sine of negative the 88 degrees is definitely not going to be a number bigger than 1 or less than -1. Okay, so keep ranges in mind for sine and cosine. I'm going to see a little bit of that later in this the class today. I'm going to keep rolling. When you stop me, then I'll slow down. Otherwise, you have,
Could you
yeah,
put the other paper back on the camera, please?
yes, sir.
Sorry about that.
The top part,
The bottom
or
part.
the bottom part. So by our knowledge that the sine of theta equals y over r and the cosine of theta equals y over r, and I have my triangle and r is there, I know x and y, you know, I could have an x equal to 0 and a y equal to 4, which means r equals 4. And then that's where I get the 1 from. But yeah, it's got to be in that range.
Okay, thank you.
You bet. Okay, finishing up 4.1. We have something called the quotient identities. And this fella right here gets a big star. It's like, that's huge. The knowledge that the sine of theta over the cosine of theta equals the tangent. And we could get into, well, where does that come from? Well, if I go back over here and I write sine of theta is y over r. Sine of theta is y over r divided by the cosine of theta, which is x over r. Somewhere along the line, you learn that to divide is to multiply by the reciprocal. So y over r times the reciprocal, and the r's cancel, and I'm left with y over x. Well, what is y over x when it comes to theta? Opposite over adjacent. Pow! It's the tangent. So now that we've looked at that, we have this fact that sine over cosine is the same as the tangent. And if I flip the left side, I do the flip of the right side, meaning the reciprocal. Cosine over sine is the cotangent. More identities. We're tucking them all away. Let's take a look at the problem. Given the cosine of theta equals -3/4 and the sine is greater than 0. Given that the cosine is that and the sine, what is the value of the sine and then the tangent? Use the Pythagorean identity. Well, the Pythagorean identity says sine squared of theta plus cosine squared of theta equals 1. Sine squared of theta plus negative square root of 3/4 squared equals 1. I believe I get 3/16 here. Sine squared of theta equals, I subtract that, and I get 13/16. Oh boy. When I take the square root, I get plus or minus square root of 13/4. I don't want both of those though. I only want one. And it says the sine of theta is greater than 0. So the sine of theta equals square root of 13/4. Chaka, chaka, chaka. Shaka Khan. What do you think about that? Good. Patrick says yes. Now, it also says find the tangent. Haha. Easy peasy, right? The tangent of theta is going to be the sine square root of 13/4 divided by the cosine negative square root of 3/4. If I multiply by the reciprocal, the 4's end up canceling. I get square root of 13 over negative square root of 3. Rationalize. Square root of 3 over the square root of 3. Looks like I get a negative square root of 39/3. I used another identity to help me out. I'm going like, yeah, nice.
I missed something. Why did you use the negative value for sine? Or no,
Yeah, the sign is greater than 0, so I didn't use the negative. I left it as a positive. That's my little square root thing in front.
okay,
Yeah,
gotcha.
yeah, I'm trying to be a little more careful like here versus there.
Yeah, no, I mostly meant on where you did the tangent of
Up
sine
here?
over cos, the top part, that 13.
Yeah,
Yeah,
that's the square root sign. I'll try to be a little cleaner.
yeah, you're good. I got you.
There it is. I get excited and I go too fast. And my bad handwriting becomes sloppy handwriting. Then I always have students say, yeah, it's not so bad, you should see mine.
Yeah,
Yeah, hey, putting all this together. I used an identity. I used an identity to find some things. Just building this inventory. Ba-da-ba-ba-ba-ba. Given the tangent is that, and it's in quadrant 3, I guess I should have figured out what the rest of the question is. Find, let's not find, because if I can't find something if it's not, let's just simply say, what is sine of theta? That's more of a question than what I had a minute ago. What is the sine of theta? Calculate. How about that? That might be better than what, because what is the sine of theta? You could say is, well, that is opposite over hypotenuse. That would be the correct answer, but oh boy. So I could do like I did up above. Say, no, yeah, I know a Pythagorean identity that the tangent squared of theta plus 1 equals the secant squared of theta. Oh man, I'd have a lot of work to do. A lot of work to do. Because I'd square it and I'd find secant, but I don't know that that's much help because the secant is 1 over the cosine. Then I'd have to use that to find the sine. And I'm going, oh boy. So here's another way to do these problems. Didn't specifically say use identities. So I'm going to go back to what I know. Tangent is 4/3 and it's in quadrant 3. That's good. All spiders taste crunchy. So I'm going to go back to DTT. Draw the triangle. It's in quadrant 3. Has to be there. Here's theta. I know that the tangent is opposite over adjacent, opposite over adjacent. Oh, I'm talking about this point right here. It's actually -3, -4. What does my hippopotamus become? My hypotenuse?
5?
5?
-5.
Nope. Distance is always going to be a positive.
Got it. Thank you.
So now I can find the sine of theta much easier because it's so opposite over a -4/5. So I could have done all that work with the identities and so forth, but I also don't want to give up when I have another option. And whoop, there it is. Questions? Questions? Okay. Somebody else showed up. Sergio, Philip, or Jephthah? Who's here?
I think it was me,
Who's me?
Sergio.
Sergio's here. Welcome to the class, Sergio.
Thank you.
Yeah. Was it because of my motivating email?
Yeah,
Yeah.
I'm gonna be honest with you, and I couldn't find the Zoom link at first. I didn't see a Zoom link in the right. So I thought we didn't have class. It was just gonna be like an internet thing.
Yeah, that was not good. So I'm glad I sent that email to get you here.
Yeah, thanks.
Okay, good. All right. Chapter 1 is a wrap. You now should be able to finish the homework and be able to take the quiz in the next couple of days. You're happy and you're all going to get A's. You're going to make this easy on me this semester. You're not going to get a 78.2 in the last week of the class. Go, hey, do you have extra credit? I need a B for my mom. No, don't do that. Don't ask me for extra credit. Do the work now. Do the orientation assignments that several of you got zeros on, and oh well, you missed them. Chapter 2. Trig functions of acute angles. Oh, they're cute, right? If they're cute, they're the little ones. That means they're less than 90 degrees. And you should be able to rip through this chart. There's our given triangle again. I'm surprised they never called this the Pythagorean triangle with the X and the Y and the R. give him credit for everything else. But I could start to fill these in. If I fill in this first column, what is the sign of A?
Y over
Y
R,
over R,
Good. Cosine.
X over R.
And finally, the tangent,
Y over X,
y over x. Perfect. What if I jump over to angle B? What is the sine of B? I gotta keep writing this down. So, ka, toa. Sine of B.
X over R,
Uh-huh, x over r. Cosine of B,
Y over R,
tangent of B,
X over Y.
x over y. Check this out. The sine of A equals the cosine of B. The sine of A, here's angle A, is the same as the cosine of B. Interesting. And vice versa. The sine of B equals the cosine of A. What do I know about angles A and B? They're both here. Here's A and up here's B. What do I know about those two? All right, well, I'll read. Go ahead, Ethan, you have an answer?
Both equal.
Well, they're not both equal. These are going to be different.
They add up to 90.
Yeah, angle A plus B equals 90. Somebody is a mind reader. Angle A and angle B add up to give me 90. So one of the things I can say is, wait a minute, B equals 90 minus A. So here I could have said, instead of B, 90 minus A. So always know that the sine of B equals the cosine of A, and that A plus B equals 90. Just little facts to tuck away. Just little facts to tuck away. All right, so if I take a look at this next one, I know that the sine of A equals the cosine of B. That's what we just talked about up above. These guys are called cofunctions. This is 40 degrees. What does B have to be?
50,
50 degrees, right? Just, simple concepts up here, we're putting them into play. Cosine of A, we know that's the sine of B. The tangent of A is equal to, actually it equals the cotangent of B, because it's a reciprocal. Tangent of A equals the cotangent of B. They're reciprocals. So if I said the cosine of 52, you could say, yeah, I know what that is. That's the same as the sine of
38.
very good. 38. I love the participation. Thank you. The tangent of 71 degrees equals the cotangent of math skills.
19.
19. We should start the class every day doing rocket math. Any of you have rocket math in elementary school? That's where
No.
you would start and they'd give
No.
you, they would give
No.
you like 20 problems. 8 plus 4, 9 plus 2. And they keep
Oh.
going quickly and you'd have to write the answers down because it was rocket math. How fast can you do those problems?
Could you slide that other page back up, please?
Absolutely.
I didn't know they called it rocket math.
Oh, so you did something like it?
Yeah, rocket math sounds like we're like doing physics.
Oh, throwing a ball up in the air, right? We're actually doing that in college algebra tomorrow because it makes a parabola shape. It's parabolic. How long
Okay,
till
thank
it
you.
reaches its peak and when does it hit the ground again and so on. Doo-doo-doo-doo-doo. See those first two problems? Well, you can't see the last one. See those two problems?
I'm sorry. Could you? Okay. Okay.
So the two solutions, theta equals 21, theta equals 30.
Thanks.
You're welcome. All right, moving on. Now, this is something that you're gonna hear over and over and over and over and over and over. So the two people who left or crashed, hopefully they're back. They're not. I can see there's still only 14 instead of 16. This is really important. This guy right here, this whole 30 degrees, 60 degrees, 90 degrees. It's called a 30, 60, 90 triangle. And that's a special case. That's a triangle that is one we're going to use over and over. This is 30 degrees. This isn't drawn to scale. This is 60 degrees. We're going to use it again and again and again. And I didn't make that very big. I don't like that. But anyhow, where does it come from? Well, I'm going to come over to this fella right here. And this is a triangle where all three sides are the same. It is called a what triangle?
Equilateral.
Excellent. Equilateral triangle. All the sides are the same. And if all the sides are the same, then all of the angles have to be the same. And if all three angles of a triangle add up to be the same thing, they add up to be 180 degrees. So that's what I'm going to start with. And you notice I made each side 2, and I did that for a reason, because we're now going to take this equilateral triangle and go, and we're going to drop straight down through the middle and cut it in half. So now what do I have? I have a triangle, comes over, goes up. Here's the 30 degrees now. I came down and made that perpendicular, and then this is 60 degrees. And I still know that this fella out here was 2. This fella down here, what's his length?
1.
1, because I took that whole bottom and cut it in half. And now that leaves me with, what is this guy's length? Opposite to 60. What is his length? Well, let's see. I don't know. It's unknown. Let's see. I'm going to pick H, just as a random number. I'm going to, or letter, excuse me, to represent an, and I'm going to say, wait a minute. I know this. 1 squared plus H squared equals 2 squared. Leg squared plus leg squared equals hypotenuse squared. 1 plus H squared equals 4. H squared equals 3. H equals plus or minus the square root of 3, but I know a length can never be a negative. So this is going to be the square root of 3. So this guy here, I just calculated to be the square root of 3. So this is a 30, 60, 90 triangle. Okay. Opposite to 30 is 1. Opposite to 60 is the square root of 3. And opposite to 90 is a 2. As these angles get bigger, these get bigger. But you notice they're not proportionally bigger. Like to go from 30 to 60, I didn't double it. So I shouldn't do that. It almost looks like negative signs. So I'm going to put dots and say 1 square root of 3 and 2. This is a special triangle, my 30, 60, 90. So now if I took a look at this triangle, there's a whole bunch of things I can do. And you can go, yep, I know the value of right away. Why don't I stay on that page? Yeah, let's do that. Stay on that. I can find things right away. Here we go. Are you ready? Say yeah. What is the sign?
Yeah.
What is the sine of 30 degrees?
One half.
So I'm doing, so yep, it's 1/2. I did my SOHCAHTOA. What is the tangent of 60 degrees? Here's 60, TOA.
Square root of 3.
Very good. Square root of 3. What is the sine of, let's see, 60 degrees or 30 degrees? Let's do the sine. Wait, we did the sine. The sine of 60 degrees.
Square root of 3 over 2.
Very good. Square root of 3 over 2. And again, I'm going to start to try to make my square roots a little bit better. So these numbers are going to become really familiar, and you're going to get excited when you see 1 square root of 3 and 2. But this is one of my 2 special triangles. All right, you're going, oh, that's good. I'm glad we did that. Yeah, me too. Okay. See what else we got. The second special triangle is one that's called a 45 degree, 90 degree triangle. 45, 45, 90. When I look at this triangle, it has a name as well. The last one was called equilateral. This one is called
Isosceles.
isosceles. And I hope I spelled that right. It's isosceles. 2 of them a match up. Third type, scalene. Mentioned that the other day. Probably never hear it again in your life, except maybe a test question or a trivia some night if you go to trivia. So I have this fellow, and I start to say, well, if these angles are the same, the legs have to be the same. So opposite the 45, I'm going to put a 1. Opposite the 45, I put a 1. And now I need to find the hypotenuse. I need to find that R. What is R?
Root 2.
Excellent. Square root of 2. Again, emphasizing my square root for square root of 2. So now I have this 1 square root of 2 idea going. And I can start to say, okay, good. What is the sine of 45 degrees? What is the cosine of 45 degrees? What is the tangent of 45 degrees? And the sine is going to be everywhere there's sine, blocking out the scenery, breaking my mind. It's going to be 1 over the square root of 2, multiply top and bottom by the square root of 2. I get the square root of 2 over 2. Thing about the cosine, it's going to be exactly the same. Square root of 2 over 2. Tangent,
1.
1. Yeah. Yeah, what's the cosecant of 45? Wait a minute, the cosecant is the same as 1 over the sine, which means 1 over the sine is the reciprocal of this. I think it's just going to be the square root of 2. What's the secant of 30? That's the same as 1 over the cosine of 30. That was one of my identities way back. So now what's the cosine of 30? All right, so I think I'm going to learn how to do this. I'm going to draw it again. I'm going to say 30 degrees, 60 degrees, 90 degrees. This was 2, and that means this one was the 1 opposite the 30. So this is the square root of 3. That was my other magic number. Cosine of 30 was adjacent over hypotenuse. So this is the same as 1 over adjacent over hypotenuse. And I know that when I divide, it's like multiplying by the reciprocal. 2 over square root of 3. Oh my goodness. Rationalizing. 2 square root of 3 over 3. Again, I did that quickly. I'm doing all the talking, which isn't good, because if I'm talking, you're not thinking, you're just writing, and I need you to start the thinking. Ah,
What angles are X and Y?
What angles are X and Y? Where are we looking? Here? Or here?
Yes. The first one.
Okay, they're both the same, so we really don't have to identify them as X and Y. Most of the time, we should think of the Cartesian coordinate system and how we draw it. So like this one would be in this quadrant kind of deal, but we don't have to worry about that right now with X and Y. We just know that when I do the sine of 30, it's opposite over hypotenuse kind of deal. The tangent of 30 is the opposite over the adjacent. Later, we're going to get into location, and some of these will be negatives, but for now, we're just worrying about getting them all of the acute angles, the one under 90. So we know they'll all be positives.
All right.
Okay. Oh boy, look at this fella. I have a 30-degree here. I have a 60-degree here. I know that's 9, and I'd like to find X, Y, Z, and W. So draw that, and then I'm going to put you into groups to see if you can figure out how I'm bigger than pairs, so that some of you are actually in a group, and see if you all can figure out how to do that problem. All right, what is this? Go away, whatever you are. I'm going to. So let's take a look and see what you came up with. What do you know here? One of the things that I'm missing is that that's a square. So that makes that a square, right? That makes that 90 degrees. So if that's 90 degrees, this is 30. This guy up here had to be
60.
And again, if this is 90, this has to be 90. They're supplementary angles. So if this is 60, this is 30. Okay, so let's take a look at the first triangle. I have X, Y, and Z. And oh boy, what do I know? Well, I do know this. This is the opposite, right? Now, so the sine of 30 degrees equals Y over 9. Now, I don't know much about the sine of 30 degrees yet. Oh, yeah, I do. Because in my 30, 60, 90 triangle, and I may just be drawing this all the time till I get it memorized. 60 triangle. This is 1. This was the square root of 3, and this was a 2. So the sine of 30 degrees is what? Sine is 1/2. So 1/2 equals Y over 9. Looks like Y is going to equal 9/2. Did anyone get that?
Negative.
No. Now all of a sudden it's like, oh, well, that was kind
Johnny
of
had it, actually.
excellent. That's good. That's good. I want to find something with X. How about this? Cosine of 30 equals X over 9. And the cosine of 30 is the square root of 3 over 2 equals X over 9. So if I multiply both sides by 9, I get 9 square root of 3 over 2 equals X. So I'm just using what I know, comparing this triangle to this triangle. Basically, what I'm setting up is something called a proportion. One ratio equals to another ratio, and I solve them. So wow, this guy ended up being 9 squared of 3 over 2. Okay, so I come back over here. I now know that y is 9/2, and that's that guy. And I could do the same kind of thing to find an answer for z and w. I could say z. Let's see, that's, hey, why not do tangent? Tangent of 60 degrees equals 9/2 divided by z. Well, these weren't the prettiest of numbers to work with, was it? Well, the tangent of 60 is square root of 3 over 1. So square root of 3 over 1 equals 9/2 divided by z. Now you're really, really bringing in your college algebra skills. Multiply by z. Z square root of 3 multiplied by 1 equals 9/2. Divide by square root of 3, z equals 9, 2 square root of 3. And of course, I would rationalize that bad boy. Square root of 3 over the square root of 3 equals 9. The square root of 3 over 6. 3 square root of 3 over 2. So I found z. You found it. Was it lost? No, it wasn't lost. I calculated z. Okay, again, I came all the way back up here and said, I'm going to use the tangent of 60, which is 9/2 divided by z. The tangent of 60 is opposite over adjacent. The tangent of 60, square root of 3 over 1, multiplied by a z divided by square root of 3. Kind of like a puzzle almost, isn't it? At least that's what I look at it as. That's a math nerd thing. Finally, I know this is 3 square root of 3 over 2. Let's do something to find w. What is, if I use 60 degrees and I want 9/2 over w, that is opposite over hypotenuse. So that's the sine. Sine of 60 degrees equals opposite 9/2 divided by w. From my triangle over here, the sine of 60 is the square root of 3 over 2 equals 9/2 divided by w. That's kind of ugly. And if we were in a classroom with a whiteboard and everything, I'd have you all up at whiteboards all over the place. Multiply by w. So now I have the square root of 3 over 2, w equals 9 over 2. Multiply both sides by 2. Is that good? Square root of 3w equals 9. Divide by the square root of 3 and rationalize. W equals 9, square root of 3 over 3. W equals 3 square root of 3. If you understand it, fantastic. If you were getting some of this, fantastic. Not an easy problem, but now that it's done, it's like, okay, give me another one. I want to try another one. Well, maybe not. Some of you are going to, hell no, I don't want to try another one. Equals 3 square root of 3. And on the test, you'll see where it says, find the exact values of something like this. Of course, that's what you would have to do. questions? A lot of lecturing going on, not enough of me sending you into breakout rooms. So start to expect that a little more as we go through. You folks interacting with each other and doing more thinking and